Hey guys, welcome to my multifamily dwelling service calc. This is going to be using the standard method. Now if you want to see the optional method, please check out my video I have on that. This is going to be doing the 2023 NEC. I do have a series for the 2020 also, so you can check out my channel for that. Now there have been a few changes in the 2023, so I will point those out as we go along. And this is a deep dive series. So this is where we're really going to take this step by step and go over every little detail on how you arrive at each part in each solution, each answer for this type of calculation. I do have a crash course series also where I take several examples that differ from each other and show you a little bit about what you might find out in the field or maybe on a test. I'm going to give you a variety. But this one, we're just going to take one example and we're going to go through it very meticulously, and we're not going to leave any stone unturned. And I'm going to show you exactly where to go for each code article, every reference that you're going to need for this calculation. Okay, before we start, I want to give you guys a little bit of background about how the code is arranged, at least how this section of the code book is arranged, Article 220. Now we're going to start in 220.40. This is a general section, because this is where it kind of explains where you start from. So I'm just going to read this. It says the calculated load of a feeder or service shall not be less than the sum of the loads on the branch circuits applied, as determined by Part 2 of this article, after any applicable demand factors permitted or required by Part 3, 4, 5, 6, or 7 have been applied. So Part 2 covers branch circuit load calculations, and Part 3 covers the standard feeder and service load calculations. In Part 2, in a nutshell, what you would be doing is you'd be taking all your branch circuit loads and you'd be adding them together to come up with your feeder or service load. And that's pretty simple, right? However, in Part 3, we are given some demand factors that we can apply because they know that we're not going to use all of our loads simultaneously in most cases. And so you don't need a service that can handle every load being used at the same time. If that were the case, we'd end up for like a 1,000 square foot house, you'd end up with like a 300 or 400 amp service, which is ridiculous. You don't need that. It's way overkill. So they know that. So they give us these demand factors in Part 3 that will apply to our branch circuit loads from Part 2. And so that's kind of how this is arranged. So remember, up here it says the calculated load of the feeder or service should not be less than the sum of the branch circuit loads from Part 2. But that's after these demand factors are applied. Okay, so that's Part 2 and 3. Now it also mentions Part 4, which is the optional feeder and service load calculations. So here you have standard calculations with the demand factors that are allowed, but you also have this optional method that allows you, it's just a different way to do the calculation. It's much faster, and it actually gives you, it gives you a lower value. And so that's, most of the time, this is a preferred method for an electrician when he's figuring out a load calc, is to use the optional method. But some cases you can't, and then other cases you wouldn't want to. You can get a lower value doing the standard, but that's pretty rare. Part 5 is farm loads, so that we don't care about that in this video. Part 6 is healthcare, and Part 7 is marinas, boatyards, and that kind of a scenario. So we are only concerned with Part 2 and 3 in this video. So this is a table I've developed so that you can see the whole problem, the whole calculation in one shot on one page. I'm just going to go over it fairly quickly, and then we'll get into it in more detail as we take an example and work our way through it. So we're going to start over here on the left side with the lighting column. We're going to take our square footage of our building, start with that, and then we're going to add our small appliances and our laundry. We're going to get a subtotal per unit, multiply by our number of units. We'll get a building subtotal. Then we're going to apply some demand factors, and we're going to get a lighting total. In the appliance column, we're going to go 220.53. These are the fixed appliances, anything fastened in place. And we're going to go through here. There are some exceptions that we'll talk about when we get to this point. But we're going to basically add them up, take our demand factor if we have one, and get an appliance total. Okay, then we move on to dryer, range, and EVSE. We're going to start with our dryer. And please check out this video on dryer calcs for much more detail. We're going to add up all our dryers. We're going to apply a demand factor, and then we're going to come up with a dryer total. Then we're going to move on to ranges. And check out my range calc video for much more detail on ranges. I go into a great amount of detail on these. We're going to take any of our cooking equipment and we're going to add it up And we're going to find a demand percentage or a KW rating for our ranges from table 220.55 and come up with the total. Lastly, we're going to take our EVSE or car charger, if we have one, and we're going to take that 100%. Once we do that, we're going to add them all up and come up with a total for the column. All right, last one, heating, cooling, and miscellaneous column. We're going to take our heaters at 100%, whether that's a furnace, ceiling heat, wall heat, whatever that might be. Then we're going to take our cooling at 100%, and then we're going to compare the two, and that's according to 220.60. Now, I have another video on non-coincident loads, which includes the largest motor. Please check that out. I have a lot of information on that video, and I explain exactly why I do things the way I do in this video, especially regarding the largest motor of the building. I'll get to that in just a moment. After that, we're going to do house loads. Now, I don't have any house loads in this video, but I do have a video that covers house loads, and that is up here. Please check out that video. It's another multifamily dwelling, but it has house loads included, so you can see how they are added to the calculation. Okay, and lastly, after everything's done, we want to take our largest motor of the building. And the reason we're doing this last is because we want to make sure we have all of our loads accounted for in the building before we try to find out which one's the largest motor. Most cases in a dwelling, it's going to be the heat pump. And again, please check out this video because I go into great detail on why I do it this way. Because I don't believe that the code wording in 220.60 matches the intent that they intended to convey. But anyway, check that video out to see what I'm talking about there. But we're going to take the largest motor of the building, add a 25% to that, and then add that to our value here. And then that's going to give us our heating and miscellaneous total. Once we have that, we're going to add up the 4 column totals and come up with a building total, VA. After we have that, we can divide by our volts, keeping in mind what phasing we have, and that's going to give us our amps. Once we have that, we can size our conduit, our feeders, and so forth. Now I have some notes down here at the bottom, and I will get to each of these notes as we cover them in the process of this calculation. Okay, here's our first example. We have a 5-unit multiplex. Each unit is 800 square foot, and then it has all these amenities here. We're not going to read through each one because I do have these listed on the next page as well. It is a 120 240 volt single phase service. There are no house loads, and we're going to try to find the calculated service load in amps. Okay, now we already read 220.40, and this is just a reminder telling us kind of what our starting point is and how we're perceiving overall what we're doing, how we're putting this together as a calculation. The first step over here is finding our square foot and multiplying by 3 to get our minimum lighting load. Now, why do we do that? Well, because it tells us in 220.41, dwelling units minimum unit load. It says in 1-family, 2-family, and multifamily dwellings, the minimum unit load shall be not less than 3 volt amperes per square foot. So we have a square foot times 3, and that'll give us our minimum lighting load. Each unit is 800 square foot times 3 is 2400. Then it says unit loads including the following lighting and receptacle outlets, and no additional load calculations shall be required. Number 1, all general use receptacle outlets of 20 amps rating or less, including receptacles connected to the circuits specified in 210.11 C3 and C4. Now those are just bathroom and garage branch circuits. Number 2, the receptacle outlets specified in 210.52E and G. And those are the outdoor outlets and basements, garages, and accessory buildings. Number 3 is the lighting outlet specified in 210.70, which are basically all the lighting outlets that are required in a dwelling. So just to recap that, what this is saying is all of these are included in this minimum unit load figure. This minimum lighting load that we come up here, this 2400 VA, includes all of these areas of the house. So you don't have to worry about putting any additional load calculations for these items. Okay, the last section here says the minimum lighting load shall be determined using the minimum unit load and the floor area as determined in 220.5C for dwelling occupancies. Now 220.5C tells us how we establish floor area. The floor area for each floor shall be calculated from the outside dimensions of the building, dwelling unit, or other area involved. For dwelling units, the calculated floor area shall not include open porches or unfinished areas not adaptable for future use as a habitable room or occupiable space. Okay, so that's pretty straightforward. And then the last sentence there says motors rated less than 1/8 horsepower and connected to a lighting circuit shall be considered part of the minimum lighting load. So all the small motors like that, they're just considered part of this load and don't have to be calculated separately. Say like a bathroom exhaust fan, say. Some of those are really small and they're less than 1/8 horsepower. You don't have to put those like under the appliance section. It'll just be included in this minimum lighting load. All right, so our minimum lighting load is 2400 VA, and that completes our first item. Next, we have small appliances, and we are required to have 2 minimum at 1500 VA apiece. Now, how do we know that? Well, 220.52a says small appliance and laundry loads for a dwelling unit. In each dwelling unit, the load shall be calculated at 1500 VA for each 2-wire small appliance branch circuit as covered by 210.11c1. Okay, now quickly let's go down and see what that says. 210.11c1. In addition to the number of branch circuits required by other parts of this section, 2 or more 20 amp small appliance circuits shall be provided for all reciprocal outlets specified by 210.52b. Okay, refer it again to 210.52b. Let's see what it says. And then I'll summarize this when I'm done. Reciprocal outlets served in the kitchen, pantry, breakfast room, dining room, or similar area of a dwelling unit, the 2 or more 20 ampere small appliance branch circuits required by 210.11c1, right here, shall serve all wall and floor reciprocal outlets covered by 210.52a, all countertop outlets covered by 210.52c, and reciprocal outlets for refrigeration equipment. So in 210.52a and 210.52c, these are just talking about all the outlets covered in the kitchen area and related rooms. So any of those outlets will be considered to be part of the small appliance circuits. So what that's telling us is we're required to have 2 or more 20 amp small appliance branch circuits, and they are to be 1500 VA apiece. So that's what we have here. Small appliances, we have 1500 each, 2 minimum. That's going to give us 3000. Now, if you notice down here in our example, it doesn't tell us anything about small appliance circuits here. That's something we have to add on our own. A lot of these questions will not tell you about the small appliance circuits. And so you've got to add those because they are required for a dwelling. So that's important to remember. So we have a minimum of 3000 VA. You'll pretty much never have a value under 3000 VA for this section right here. But you may have maybe 3 or 4 appliance circuits. And so you would have, 4,500 or 6,000 here for a VA total. Okay, now let's finish up in this section. It says, where the load is subdivided through 2 or more feeders, the calculated load for each shall include not less than 1500 VA for each 2-wire small appliance branch circuit. So that doesn't really change much. It's just telling you that if you have 2 separate feeders that are feeding your circuits into your kitchen area, they each have to be 1500 VA. And then it tells us these loads shall be permitted to be included with the general lighting load and subjected to the demand factors provided in table 220.45. Now we'll be talking about table 220.45 in the next section. So right now we are calculating the loads for our general lighting load, and that's going to end up being down here when we're done. Okay, now there is an exception to this part A. It says the individual branch circuit permitted in 210.52b1, exception number 2, shall be permitted to be excluded from the calculation required by 220.52. Okay, now 210.52b1 is down here. We already read that. Now there is an exception to this that I don't have printed out here, but all it is really talking about is any outlets that you may have in the kitchen area, say, that are not for appliances or are for dedicated appliances. So like, let's say you have a microwave, like a built-in microwave that sits above an oven maybe. It's got an outlet in the back that it plugs into. Well, that does not have to be part of the small appliance branch circuit. It's accepted here. Another one would be like under cabinet lighting or upper cabinet lighting where the lights plug into receptacles. Those receptacles are accepted from being on the small appliance circuit. Anyway, you can read that exception in your code book, and that might clear up some questions you may have on that. But that takes care of our small appliance circuits. Moving on, we have laundry next. Laundry, we're required to have one minimum laundry circuit at 1500 VA apiece. How do we know that? Well, we go on to 220.52b. It says a load of not less than 1500 VA shall be included for each 2-wire laundry branch circuit installed as covered by 210.11c2, which is right down here. 210.11c2 says, in addition to the number of branch circuits required by other parts of this section, at least one additional 20 amp branch circuit shall be provided to supply the laundry receptacle outlet or outlets required by 210.52f, right here. 210.52f says, in dwelling units, at least one receptacle outlet shall be installed in areas designated for the installation of laundry equipment. So that's important because it's telling us that if we have an area designated for laundry, then we have to put provisions for a laundry circuit in there, and we have to work it into our calculation. So as a recap, we're told that we need at least one 20 amp branch circuit, and it's got to be rated at least 1500 VA. So that's what we have here. One minimum, 1500 each. There we go, 1500 for a laundry circuit. Now one quick note down here, under 210.11c2, it says this circuit shall have no other outlets. So you can't run this circuit to other rooms outside the laundry room. It's got to be dedicated for laundry and laundry related equipment. Okay, now going back up here, we still have one sentence left here. It says this load shall be permitted to be included with the general lighting load, all right, just like we did up here at small appliance, and shall be subjected to the demand factors provided in table 220.45. Okay, so just like small appliance, this is part of the general lighting load. It's going to be made up here. Okay, one last thing before we leave the laundry part of this. There are some exceptions to 210.52f, and they're very important, especially considering we're dealing with multifamily here. Exception number 1. A receptacle for laundry equipment shall not be required in a dwelling unit of a multifamily building where laundry facilities are provided on the premises for use by all building occupants. So all this means is that if you have a building that has like a common laundry area for all the occupants to come and use the same facility, and you don't have any laundry facilities in each unit, then you don't have to put a laundry value here because this is per unit. And so this would be 0. Now let's look at exception 2. It says a receptacle for laundry equipment shall not be required in other than one family dwellings where laundry facilities are not to be installed or permitted. So here it's talking about a building where there are no laundry provisions whatsoever. And if that's the case, again, you do not have to put a value here. It'd be 0. So that's something very important to keep in mind as we deal with multifamily dwellings. Okay, so once we have these three numbers, we add them together and we come up with a subtotal per unit, which is 6900 VA. So that is our general lighting load per unit. So in order for us to get the general lighting load for the whole building, we have to multiply by our number of units. Now this is a 5-plex, so 6900 times 5 is 34,500 VA, and that is our building general lighting load. Okay, now that we have the subtotal of our building, it's time to see if we have any demand factors that we can apply. And for that, we're going to go to table 220.45. It says general lighting. This is the table I mentioned in the last slide that I said we'd be talking about in just a moment. And here we are. It says the demand factor specified in table 220.45 shall apply to that portion of the total branch circuit load calculated for general illumination. They shall not be applied in determining the number of branch circuits for general illumination. Okay, that last sentence, all that means is you can't use this table in figuring out how many lighting circuits you have in your house or in your dwelling, or in this case, in your multifamily dwelling. That is based on square footage, and that's a different calculation. This is strictly for determining what your demand factor is for your general lighting load that you already figured out. Okay, so this table has your occupancy types on the left side and then their demand factors on the right. For our type, we have a dwelling unit. It's a multifamily dwelling unit. And for dwelling units, you take the first 3,000 VA at 100%. From 3,001 to 120,000, you take that at 35%. Anything over that, you take it 25%. So in our case, we take the first 3,000 at 100%. So we're going to write 3,000 right here. Now that would leave us with 31,500. So we're going to take that at 35%. 35% of 31,500 is 11,025 VA. We don't have anything beyond that, so this will be 0 for the remainder. So we'll just add 3,000 to 11,025. We come up with 14,025 VA, and that is our lighting total. And just as a side note, if you have any questions as to where this 117,000 comes from, that is how many VA are between 3,001 and 120,000. So that's just this next section here is 117,000 worth of VA. Okay, moving on to appliances. Appliances are dealt with in 220.53, and this is for dwelling units only. It says applying a demand factor of 75% to the nameplate rating load of 4 or more appliances rated quarter horsepower or greater or 500 watts or greater that are fastened in place and that are served by the same feeder or service in a one-family, two-family, or multifamily dwelling shall be permitted. This demand factor shall not apply to the following. Okay, so we'll come back over this in more detail, but let's get through these exclusions first. These 5 items are excluded from applying this demand factor. Household electric cooking equipment that is fastened in place, so ranges, cooktops, stoves, ovens. Clothes dryers, space heating equipment, air conditioning equipment, and then this is new to 2023, the EVSE, the car chargers and such. These have been pulled out of regular appliance column and are now treated on their own, and we'll have our own section for that. So none of these can be included in this appliance load scenario. And that's what I have right here. I have a note that says no cooking, dryers, heat, AC, or EVSE. And then I also have the note saying that anything less than a quarter horsepower or 500 watts has to be taken at 100%, no matter how many there are. So looking back here, it says applying a demand factor of 75% to the nameplate rating of 4 or more appliances. So if we have 4 or more appliances, we can apply 75% to any appliances we have, except the ones that are smaller than quarter horse and 500 watts. They have to be taken at 100%. If we have less than 4 appliances, they have to be taken at 100% also. So what we do is we list our appliances here, we add them all together, and we'll come up with a subtotal per unit. So let's go ahead and add in our data. We have a dishwasher, 1,200. We have water heater and disposal. You see those right down here, dishwasher, water heater, and disposal. We put in their VA, their nameplate rating here. We add them all together. We get 6,200 total. And so this is per unit, remember. And then we're going to multiply by the number of units. It's a 5-plex, so we're going to multiply by 5. We come up with 31,000 for the subtotal of the building. Now pretty much anytime you have a multifamily dwelling, you're going to definitely have your more than 3 appliances. So you're always going to be able to use this 75% demand factor. Even if you had a really small duplex, you're going to have at least 2 fixed appliances usually. And that's going to put you over your 3. So we will apply 75% to 31,000. That gives us 23,250 VA for our appliance total. Okay, moving on to the dryer range and EVSE column. We're going to start with our dryers, and I'm going to explain a little bit about how to calculate dryers here, but for much more detailed info, check out my video on dryer calcs. I have a lot of information on dryer calcs. But we're going to go to 220.54. It says electric clothes dryers for dwelling units. The load for household electric clothes dryers in a dwelling unit or units shall be either 5,000 watts or volt amps or the nameplate rating, whichever is larger. That's very important, for each dryer served. Okay, so what's that saying is each dryer has a minimum of 5,000 watts that has to be applied to it. Now, if the nameplate rating is larger than 5,000 watts, then you have to put the nameplate rating. And then it says the use of the demand factors in table 220.54 shall be permitted. So here's table 220.54. And we'll come back and finish this other part up in just a moment. So we have written right here, we have dryers at 5,000 minimum each, and nameplate if over 5,000. Now we had a 4,600 watt dryer, but we had to put a minimum of 5,000 for each dryer. So we're going to add up all of our dryers. In this case, we just multiply by 5. 5,000 times 5 is 25,000. Then we're going to go to table 220.54 to find our demand percentage. Let's see, 220.54, we go down to 5 dryers and go across, and it tells us we have a demand factor of 85%. So we're going to take 85% of 25,000, and we're going to come up with a dryer total of 21,250. Okay, now let's go back and read a little more. It says where 2 or more single-phase dryers are supplied by a 3-phase 4-wire feeder or service, the total load shall be calculated on the basis of twice the maximum number connected between any 2 phases. Okay, that's a mouthful, and it's a little bit complicated, but basically here is the formula for that. If you have single-phase dryers on a 3-phase service, this is a formula you would use. I'm not going to go into how this works or explaining this right now because I have that dryer video explains all of this in great detail. So just check out my dryer video and you'll be good to go. Now, one last thing, it says kilovolt amperes or kVA shall be considered equivalent to kilowatts for loads calculated in this section. Okay, and they're just telling you what we all do pretty much anyway in calculations is we just substitute kVA and kilowatts and kind of use them interchangeably because for our intents and purposes here, it doesn't make enough of a difference to be significant. So they're just acknowledging that. All right, moving on to ranges. Now, just a quick note, when we say ranges, we're generally talking about any cooking equipment in the kitchen, any fixed in place cooking equipment. We kind of take the shortcut as electricians, we just use the term range for all of it. Now, but there are certain situations where a range is different from how a cooktop or an oven may be calculated. And I talk about that a lot in my range video, and I'll put the link up here in just a moment for that. But let's start by reading 220.55. It says electric cooking appliances in dwelling units and household cooking appliances used in instructional programs. The load for household electric ranges, wall-mounted ovens, counter-mounted cooking units, and other household cooking appliances individually rated in excess of 1 3/4 kW shall be permitted to be calculated in accordance with table 220.55 over here. And then it has the same note that the dryers had. It says kVA shall be considered equivalent to kW for loads calculated under this section. Okay, no big deal. Okay, so this table 220.55, this confuses a lot of people. It's not really that complicated, but it is kind of lengthy and there is quite a bit to it. But once you kind of figure out what their methodology is, it really is kind of simple. But let's see how we're going to use it in this case. So first of all, real quick, I'm just going to explain what the table is. On the left, you have your number of appliances. You have a column A, B, and C. Now, A and B are demand factor percentages. And that's important to know that these are percentage values. Column C is not. Column C is a kW value. So that can get kind of tricky, especially when you get down here when they're kind of similar. Like you get down here to, say to 32, you got 32% or 30 kW. And if you take it wrong, if you think this means percent or that means kW, you'll get mixed up on your values and your calculation will be wrong. So anyway, make sure you keep that straight. Now, one note in the table heading, it says column C is to be used in all cases except as otherwise permitted in note 3. So it's telling you you're going to default to column C unless you're permitted to use column A or B. And note 3 tells you when you can and can't use A and B. And I'm not going to get into that in this video. That is in my range video. But there are several notes to this table that I don't have listed here because they don't apply to us, except for note 3. And all that says is that if your range falls within this range of column A, you can use column A. And if it falls within the range of column B, you can use column B. So in our case, we have a 6,000 watt range in each unit. So 6,000 times 5 is 30,000. And so we're going to go here. And which column does 6,000 fit into? Now remember, we're told we can use column C. And if we use column C for 5 ranges, we come up with 20 kW. and that would be our value we would use. However, 6 also falls into the range of column B. It's between 3.5 kW through 8.75 kW. So we go down to 5 ranges under here, and it says we can use a 45% demand factor and apply it to our range total. So if we take 30,000 and apply 45%, we come up with 13,500. So that's much lower than the 20 kW. So our range total is going to be 13,500 for this problem. Okay, now going back up here and finishing this off, again, it has the same sentence that we had for the dryers. It says where 2 or more single-phase ranges are supplied by a 3-phase 4-wire feeder or service, the total load shall be calculated on the basis of twice the maximum number connected between any 2 phases. So again, here is the table for that. And this is actually a simplified table. You're going to want to go to my range calculation video to get all the details on single-phase ranges on a 3-phase service, and also on learning all the notes to the table and how every which way the table can and will be used is in that video. Like I said, this is a simplified 3-phase calculation. There are actually a number more options than this available. Okay, so that does the total for the range. The next thing is the EVSE, the car charger. We don't have one in this calculation, but if we had one, we would just take it at 100% and put it right there. So if each unit had an EVSE, we would take that times 5 and put our value here. All right, so once we have those values, we have the dryer total and we have the range total and the EVSE total. We add up these bold numbers here and we come up with 34,750 VA for our dryer, range, and EVSE total. Okay, we're moving on to our last column now. We got heat, cooling, and miscellaneous. First, we're going to start with our heating. Now, you're going to notice that these are not in sequential order, the way the code book has them, and there's a reason for that. Now, I'll tell you the method to my madness. They have motors written here at 220.50, but I believe when we get to the second part of motors, when we get to the largest motor of the building calculation, we want to do that very last. That's why I hold this to the very end down here, largest motor of the building. So I have that down below the other two. I think it's most important to take the heating and then the air conditioning or cooling, because then we're going to compare them because of 220.60 non-coincident loads. We're going to compare them, take the larger, and then we're going to add our largest motor once we have all that figured out. Okay, so I just want to give you a little overview first. So let's start back up here with the fixed electric space heating. It says fixed electric space heating load shall be calculated at 100% of the total connected load. Okay, so that's pretty easy. There are no demand factors for heating. It's 100%. It says, however, in no case shall a feeder or service load current rating be less than the rating of the largest branch circuit supplied. Okay, so your branch circuit cannot be larger than your feeder or service. Now there's an exception here, but I'm not even going to read it because it doesn't really pertain. It just says the authority having jurisdiction can pretty much do whatever they want, which is true. Okay, so we have a 7 kW furnace. We're going to put 7 times 5 because we have 5 units. That equals 35,000 VA. Next, we're going to go on to our cooling. We're going to go down here to air conditioning equipment. It says the conductor sizing requirements specified in Part 4 of Article 440 shall be used to determine air conditioning loads for hermetic refrigerant motor compressors. What that tells us is you take it at the nameplate rating, 100%. So that is our heat pump at 3,200 watts times 5 is 16,000 VA. Okay, now we go to 220.60, and this is where we deal with non-coincident loads. It says if it is unlikely that 2 or more non-coincident loads will be in use simultaneously, using only the largest load or loads that will be used at one time for calculating the total load of a feeder or service shall be permitted. Okay, piece of cake, right? You just take the larger of the two. In our case, it's 35,000. So we're going to put that right here in bold. Now I'm not going to go over the rest of this because this is the problem area of 220.60 that I talked about. And I discussed this in great length in my non-coincident load video. And that includes the largest motor. because they're so related. I have those in the same video, so check that out. And I'm going to move on. Next, we have our house loads, if they apply, which they don't in our case. And then lastly, we're going to take the largest motor of the building. And in this case, and in most residential cases, the largest motor is going to be your compressor motor of your heat pump or air conditioner. And that's what we're going to do here. We're going to take 3200, which is one unit, because remember, this is for the service, so it's just of the whole building what the largest motor is. So one of these air conditioner units, 3200, we're going to take 25% of that, which is 800, and we're going to add it to our 35,000. That gives us 35,800 VA for our heating and miscellaneous total. Okay, now that we have that, we're going to add up all four column totals. And we're going to come up with a building total of 107,825 VA. We're going to divide by our volts, which is 240, single phase, and we're going to come up with 449 amps. And that is our service total. Now, just for fun, what if this was a 208 three-phase service? Well, for a 208 volt three-phase service, you're going to take 107,825 and you're going to divide that by 208 volts times the square root of 3, and that's going to give you 299 amps. So you can see what a big difference that is, just going from single phase 240 volt to three-phase 208 volt. I just thought I'd throw that in there so you could see it in case you're curious. But our actual total is 449 amps. Okay, now here is just a blank sheet. I took the color out so it's easier for you to screenshot, and you can print out copies. You can use it as a cheat sheet, whatever you want to do with it, have at it. Okay, thanks for watching, guys. I appreciate it. If you liked what you saw here, please give me a like. And if you haven't subscribed to the channel, please do that. It will help me out a lot. I have a lot of other videos out there, a lot of other calc videos. I have a 2020 series that's done, and I'm working through my 2023 series, and I'm also putting out some auxiliary videos also. And let me know what else you want to see, what kind of videos, because I want to make videos that are interesting to the people who are watching. So anyway, thanks again, and I will see you next time.